one more time for you guys to see. All right, so I'm going to start class. And we are moving on to lesson 2.3, investigating gene copies. All right, so for our closing task, by the end of today, you're going to be able to answer an investigation question. You are going to be able to provide evidence that you have 2 copies of a gene for each feature. Right? So our warm-up, it's a little different today. It's not an amplified warm-up. I wanted to make something kind of fun. And so if you could have a superpower, what would it be and how would you get it? So I want you to answer this in your Google Doc. There's a red box there that you can type it in. So if you could have a superpower, what would it be and how would you get it? So Spider-Man got bit by a spider and he has all these spidey senses. He can climb on walls. He can shoot webs. Somebody told me, I haven't watched the Hulk, but I do watch Marvel movies. I just didn't watch the Hulk. And they said he got hits from gamma rays. And then Captain America was put in this little portal thing, and it made him all big and strong, and he could run fast. So if you could have a superpower, what would it be and how would you get it? It could be different from these guys. Maybe you want to be Spider-Man, but how would you actually get that superpower? All right, take another minute. Make sure you write that in your Google Doc. All right, I want to hear what some of you guys put. What would be your superpower? Y'all can put it in the chat, or you can. What would you be?
Thor.
You'd be Thor. Thor's a good one.
Yeah, I get struck by lightning.
Struck by lightning? That's how you would. Dang.
Yeah.
That's a good one. Super speed. Somebody said invisibility in my last class, which is a pretty good one. Nobody else wants a superpower? I think I'd want to teleport. I think that'd be really cool. I know it's not really, I guess it's a superpower. Madison, that's what you said? I've always wanted to be able to get to different places really fast. All right, Braxton want to be the Flash. Time travel or shake? Ooh, okay. I haven't heard of that one, Zion. That's a good one though. So you could be hit by anything and it wouldn't hurt you. These are good. You guys are thinking out of the box. I like it. All right. So with that, all of those superpowers are going to require some type of mutation to a gene or even multiple genes because you have all these superpowers. So obviously it probably didn't just affect one gene. It probably affected multiple genes. Okay. So we are going to watch this video of the Scottish Fold cats one more time. Hopefully you watched it for homework. a few classes ago, and it's going to deepen our understanding of mutations. All right, I'm going to share my sound, and make sure you are looking at my shared screen just because this will not play in the actual Peer Deck. So make sure you're watching my shared screen.
This is a Scottish fold cat. Why do these cats have ears that fold when most cats' ears stick straight up? It started with a cat named Susie. Her parents both had normal ears, but Susie's ears folded over. Susie had a new trait because of a mutation to her genes when they were passed down from her parents. Each gene is an instruction to make a protein molecule with a specific structure. The structure of a protein molecule is important because it determines how it connects with other protein molecules. Interactions between protein molecules, like the way they connect to one another, determine an organism's traits. The mutation to Susie's genes changed the instructions for the cartilage her body makes. Cartilage is flexible, bone-like material. It's what gives ears their shape. The changed gene made a different protein molecule for the cartilage of Susie's ears. Now, the cartilage wasn't strong enough to hold up the ears anymore. So when Susie was born, she had the new folded ears trait. And that is how we got the first Scottish fold cat. Mutations are totally random, so there's no way of predicting which genes will be changed or what kind of effect they'll have. In fact, a mutation may not have any effect on an organism's traits. These two flowers look exactly the same, even though one has a mutation. But in Susie's case, the mutation did have an effect. This is how Susie got her famous ears. She passed this trait down to her offspring. We have Susie's mutation to thank for the Scottish fold cats we see today.
Mutations, and so we're kind of going to wrap up mutations in the back of our brain right now. If you were not here on Friday, we put this definition in our notebook. And so we went over mutations a little bit on Friday. So if you were not here, make sure you add this definition to your digital notebook. So mutation is a random change to a gene that sometimes results in a new trait. Alright, so if you did not write this down, make sure you do. If you've already got it down, great. You don't have to write it again. Maybe you have about 10 more seconds. Make sure you have this down. You should have your digital notebook open. Alright, so we're going to move on to activity 2, which is the simulation. So what we're going to do is we're going to open sim and gather some evidence on why some organisms make 2 proteins for a feature, while other organisms only make one type of protein. And we're going to go over key concepts. Alright, so we're going to investigate this question today. So why do some organisms make one type of protein for a feature, and other organisms make 2? So when I'm talking about making one type of protein for a feature, if we look at Anne here, so Anne is one of our spiders in our simulation. Anne makes one type of protein for the versatile feature. We know this because if we look inside of Anne's cells, or Anne's cell, we only see one protein. And she only has one of these little red proteins floating around in here. Alright? Now, if we go and we look at Leo is another one of our spiders. Leo makes 2 types of proteins for this versatile feature. And they're circled in his cell right here. He has both of the proteins in his cell. And only had one of them. All right, so why is that? We're going to look at a little bit more today. All right, but before we get into that, before we get into our sim, why do you guys think that some organisms make one type of protein for a feature while other organisms make two? So go ahead and respond in our pear deck. This is one of our, I think, 3 questions in our pear deck. If you have not joined, I'm going to send the link in the chat one more time. Oops, didn't mean to do that. But if you have not joined our pear deck, make sure you do, and you're answering this question. So this is kind of us making a hypothesis right now. So why do you think some organisms make one type of protein for a feature while other organisms make two? And you do not have to be correct on this. All right, it could be a mutation, possibly. Just because they're different, right? They get passed down differently from their parents. All right, keep answering these. All right, so make a hypothesis on why you think some organisms make one type of protein or a feature while other organisms make two. Okay, proteins are structured differently. All right, I get where you're going with this. It requires different types of proteins to do one function. So I guess when you're talking about the traits, right? So maybe you want, or you have a low silk flexibility. Maybe you have do you have different proteins when you have low silk flexibility than when you have high silk flexibility? You gotta think about that, right? So this is what we're going to be investigating today. This is the question that you guys are going to be able to answer by the end of class. All right, so for mission 1 in our simulation, I want you guys to go into your Google Doc. You're going to click here for the simulation. All right, there's a spot that says click here for the simulation. So what you're going to do is you're going to open that sim, and I'm going to go over our instructions. So you need to pick a feature. So this could be silk flexibility, it could be venom, it could be body color, stripe color, anything but body size, right? Anything but body size. You're going to pick a feature. So those features are up top in the simulation. You can stick with silk flexibility if you would like, but I would suggest going with something different, something that you like to look at. So maybe you want to look at the venom. Maybe you want to look at their body color or their bristles. All right, so pick a feature. Next, you're going to find proteins. So what you need to do, you're going to go through, after you pick your feature, you're going to go through some of these spiders. I need you to find 2 different spiders. Okay? I need you to find 2 different spiders, one that has only one type of protein, and another that has 2 types of proteins. Just like we looked at the bristles, the example I gave you guys a second ago, you're going to do this with the feature that you pick. So if you pick venom, you need to find a spider that has only one type of protein floating around in their cell. You also need to find another spider that has two types of proteins floating around in their cell. All right. Now, in your Google Doc, if you're looking at my shared screen, there is a record your results here section. And so you're going to record the feature you observed. You're going to record the name of the spider that makes one type of protein for this feature. And then you're going to name the spider that makes two types of proteins for this feature. Once you get done with that, in the space below, you're going to list some ideas for why you think one of the spiders makes one type of protein while the other spider makes two types. So I know that's the same question, but that's the question that we're going to be looking at all day or all class. All right, but we're just looking at another example. So I'm going to start a 4-minute timer. Make sure you follow these instructions. So get on that simulation. Pick your feature. Find the proteins. You're getting two different spiders. So one of those spiders will have one type of protein. One of those spiders will have two types of proteins in their cell. As soon as this starts, y'all can go if you would like. Get a little bit of extra time. I'm just waiting on our timer. All right, y'all. So hopefully you got into your simulation and you were able to find those 2 spiders. Okay. Now, there is a second mission to the simulation. Okay. So you had your first mission. You picked your feature. You got your 2 spiders. Now, with those 2 spiders, I'm going to go back into our peer deck. With those 2 spiders, you're going to change the spider's genes so both spiders produce the same proteins for the feature that you guys selected. Right? You're going to change the spider's genes so both spiders produce the same proteins for the feature you selected. And so what I mean by changing the genes or changing the proteins, in order to change the genes, somebody tell me what you have to where you have to go for that. In order to change our proteins, what do you have to change? Somebody let me know in the chat, or you can unmute yourself. In order to change the proteins, what do you have to change? What makes our proteins, guys? You can put it in the chat. You can unmute yourself. What makes our proteins? We learned this last week. Guys, it's right here on this shared screen. What makes the proteins? Okay, Zyvon says the ribosome. So our ribosome makes the proteins. Okay, that's where our proteins are coming from. But what are the instructions? Who gives them the instructions? The genes, right? So our genes are the instructions to make the proteins, right? So in order to change the proteins, we need to change our genes, okay? We need to change our instructions. So if you're looking at my shared screen, in order to change your proteins, you have to change your genes. So in order to change your genes, you can click on these little drop-down boxes here. Okay, so you've got your 2 spiders, hopefully. Now what you want to do is you want to make those 2 spiders have the same trait. Also the same protein. Because if you change the protein to the same thing, you're going to have the same trait. Right? So if you can either change the spider that has 1 protein, or you can change the spider that has 2 proteins. But you need to make sure that they have the same proteins in their cell once you change them. Okay, so if I wanted to make this spider who has 2 different proteins only have 1 protein, I would need to change the gene version. Okay, now I only have 1 protein circulating around in my cell. Okay, I'm going to give you guys a few minutes. There is a question on your Google Doc. So in the box below, all you're doing is describing what you did and what you observed in the simulation. Okay, change your spider's genes so both spiders produce the same proteins. And in the box below, you're going to describe what you did and what you observed in the simulation. So I'm going to put this timer on, give you guys 3 minutes, and then we're going to move on to a reading. Make sure you guys are doing this in your Google Doc. You're responding to that question in your Google Doc. You guys got about a minute and a half. All right, so you should have mission 1 and mission 2 done. All right, so I'm going to go over this one more time. If you're still working, keep working. I want to make sure we're done with missions 1 and 2 before we move on to the reading. All right, so for mission 1, you should have picked a feature. You should have found your 2 spiders. So one has 1 type of protein, the other has 2 types of protein floating around in their cell. All right. All you were doing here was just listing some ideas as to why you think that one of them has 1 type of protein and the other has 2 types of protein. For mission 2, what we just got done, or what you should have just gotten done, you should have changed your spider's genes. So up in the top right corner, you were able to change the genes so that both spiders produce the same proteins for the feature you selected. All right, so if you selected venom, you should have changed the proteins to be the same thing for each of them. So one was either they have venom or they're venomous, or the other one is non-venomous. Okay, so both spiders should have had the same proteins, they should have had the same traits. I've been muted this whole time, guys. Thank you for telling me, Shelby. All right, I'm going to go over that one more time because I was muted the whole time. So you should have done mission 1. You should have opened the sim, picked a feature, and found those 2 spiders. You should have listed some ideas below in that green box and then moved on to mission 2. Mission 2, you had to change those genes so that both of the spiders had the same proteins for the feature that you selected. All right? All you were doing in the box was describing what you did and what you observed. Now, we're going to move on. We've got about 20 minutes. This is our last activity that we're going to do together as a class. Okay? This is our part of the reading. So we are going to visit this little piece of reading again from the hemophilia article that we read last week. All right? I want you guys to answer this question. How does changing the spider's genes affect their proteins and resulting traits? So how does changing the spider's genes, which is what we did in mission 2, affect their proteins and resulting traits? Go ahead and answer and pair that. And this is our second question. And we've got one more question to answer after this. Alright, so if you are not on the pair, you need to make sure you get there. Hopefully you have pounded this into your head and it is stuck there permanently on how changing genes affects proteins and traits. I hope you guys this is clear to you why this happens. If not, we're going to keep going over it. Okay, so how does changing the spider's genes affect their proteins and resulting traits? You should be answering Paradox. I've got 4 out of 17 answering Paradox right now. You guys got to make sure that you are following those timers and getting those things done within that time frame. Because we've got to keep moving on to our different activities that we have. Just like if we were in class, you would have a certain amount of time to get done with an activity. It is the same here. Changing the genes affects the traits, affects how many protein molecules there are. Changing the genes does not affect how many there are. It affects the different types of protein molecules. And changing spiders' genes affects their proteins and resulting traits. You change the gene that makes up their proteins, and then the specific protein that makes up their traits will change the trait completely. Good. So for these people that don't know yet, or you're not sure, if you were doing the last activity, you should have seen that if you change the gene, you change the protein in your cell, right? Genes are the instructions for proteins. We learned that last week. If we change those instructions, we change the type of protein that is in the cell. Now, when we change the type of protein in the cell, that in turn changes the trait. So if you have low silk flexibility in a spider, and you change those proteins, it could possibly change to a medium silk flexibility or a high silk flexibility. So when you change the genes, you change the proteins. When you change the proteins, you change the trait. All right, it's kind of a monopoly effect. All right, so our key concept is an organism has 2 copies of a gene for each feature. And the reason that we know this is because in our simulation, those two, when we're talking about the gene versions, those two genes, those two copies of the gene, that's what we were changing. All right, so an organism has two copies of a gene for each feature. Add this to your digital notebook, and then we're going to move on to the reading portion. All right, so an organism has two copies of a gene for each feature. Take about 10 more seconds, get that down. Hopefully you have your digital notebook open. You should, because that's what we were supposed to have open at the beginning of class. Right? So in this diagram, we can see that the gene copies in the nucleus of a venom gland cell, which it's pointing at right here, these are the copies of a gene. The two copies of a gene can be the same version or different versions. So if you were looking at the venom feature, you saw V1, V2, and V3. This right here is showing me that they have the same versions because it's V1, V1. Now, if they had different versions, it may look like V1, V2 or V2, V3. Okay, but these have the same version. All right, so for our reading, we're going to review and add the vocab and key concepts to our digital notebook and answer a question using some words from our word bank. All right, we're going to reread a part from the hemophilia, proteins, and genes article that we read last week. It's going to help us understand why some organisms make one type of protein for a feature, while other organisms make two. All right, so I'm going to only give you guys about 3 minutes because it is a very short little part from the article. And so as you read, you're going to pay attention to how this diagram right here on the left fits to the text. So how this diagram and the text fit together. Okay, so in your Google Doc, this is what you have. You do not have to answer the question below just yet. We're going to answer that at the end of class. But you're going to read this part right here, and you're going to look at this little diagram to the right. I'm going to give you guys 3 minutes, probably a little less because we are running a little short on time. But go ahead and start reading that on your Google Doc. All right, so when you get done reading, if you are done, make sure that you are trying to think about how the text that you just read and this diagram kind of fit together. If you understand that, start thinking about how the reading and the simulation are starting to kind of come together. You got a little under a minute. About 30 more seconds. All right, so from that little reading, we've got two new words that we're going to add to our digital notebook. Okay, we've got two new words we're going to add. So that first word, kind of a big word. Actually, both of them are kind of big words. We've got homozygous. So homozygous means having gene versions that are the same. Homozygous means having gene versions that are the same. All right, pull up your digital notebook. Hopefully you have it in a tab and write this down or type this out. All right, take about 15 seconds. Homozygous means having gene versions that are the same. All right, I want to put this in the chat. Okay, we're going to move on to heterozygous. So heterozygous means having gene versions that are different. So we see the difference there. Homozygous is having gene versions that are the same. Heterozygous is having gene versions that are different. Okay, I put both of those in the chat. We got to move on to our next slides. All right, so how can we use those two terms, so homozygous and heterozygous, to describe what you observed in the simulation? So you picked those two spiders. How can you use those two terms to describe those two spiders? All right, this is our last question in the Pear Deck. So make sure you're answering that. How can you use the terms homozygous and heterozygous to describe what you observed in the sim? So once you've written something in there, you can go ahead and get out of the Pear Deck and just look at my shared screen. All right, once you have typed out a response in your Pear Deck, you can go ahead and get out of there. There's not another question in there. All right, I'm guessing this one means to say by the different feature. And if you mean to say that, what do you mean by the different feature? Okay, I'm guessing this one's saying by the different proteins. So if they are homozygous, they have the same proteins. If they are heterozygous, they have different proteins. All right, so we know homozygous means that it's having a gene version that are the same. So if we're looking at the simulation and we're looking at the gene version, which is up there at the top right, that means that you have the same gene version, right? If it's heterozygous, if that gene version is heterozygous, if you're looking at the simulation up at the top right, that means those are different. So if those are different, that means you have different proteins, right? If they're the same, you have the same proteins in the cell. Okay, so make sure you're responding to this question in our paradigm. It does not mean if they changed or stayed the same. We should be talking about the genes and the proteins. So if you have a homozygous gene version, you have the same proteins. If you have a heterozygous gene version, you have different proteins. All right, so first when we looked at two different spiders, one of them was heterozygous for their genes. Okay, so good. You're good. I like where this one's going. So at first you picked two spiders. One of them was heterozygous, the other was homozygous, right? And so for mission 2, you had to change one of those spiders. So you had to either change one of those spiders from heterozygous to homozygous or homozygous to heterozygous. Okay, so homozygous have one protein, heterozygous have two proteins. Right? Good. Homozygous is the same, heterozygous is different. Right? So here is kind of a rundown, kind of a review of what we looked at. So in the sim, we observed that organisms can have either two copies of a gene that are the same version, look up here, or they have two different versions. So F1 is homozygous, F1, F2, it's heterozygous because they're different. Right? In this reading, we learned that scientists have those specific terms to describe the combinations of gene versions, and those are called homozygous and heterozygous. All right, the last two things that I want to give you. I need you guys to respond to the investigation question using the evidence. So what we just talked about, I want you to answer that question here in that purple box. All right, so using the evidence from the sim and the reading, you're going to respond to that investigation question. All right, now the last two things I want to give you. Before you start answering that investigation question, or if you already have, we're going to write these two key concepts in our digital notebook. These are the last two key concepts we're doing for this lesson. And then I'm going to explain the other two assignments that you have for this week. And we will be out of here. I know we've only got 2 minutes, but we've got to get these two key concepts down into our digital notebook. All right, so what I'm going to do is I'm going to write this in the chat if you guys want to copy and paste it. So this key concept says the two copies of a gene for each feature can be the same version, which is homozygous, and provide instructions for only one type of protein. So if it's homozygous, it has the same two genes for the gene version, and it provides instructions for only one type of protein. So when we think of homozygous, that little word at the beginning, homo, means the same. Right? Zygous has something to do with the gene version. It's the same gene version. Now, This next key concept almost looks the exact same, but it's talking about heterozygous. So I'm going to put this into the chat if you want to copy and paste this one as well. So the 2 copies of a gene for each feature can be different versions, which is heterozygous, and provide instructions for 2 types of proteins, right? So if something is heterozygous, that means that it is different. It is different. All right, and you're going to have 2 types of proteins if you have a gene version that is heterozygous. What's up?
I think that's 2 key concepts in the lecture.
If it says chapter 2, lesson 3, then yes. I don't remember which slide it is, but it should say chapter 2, lesson 3. All right. Now, make sure you get those 2 key concepts down. Those are in the chat. I'm going to tell you about, so this homework is not going to be an Amplify thing. You guys already finished your Google slides, so you don't have to worry about that. This homework is not going to be due till Friday. All right. I have my surgery on Thursday, so we will not have class we won't be meeting on Zoom on Friday. And so this will be an activity that if you didn't get done with it throughout the week, you can do it on that Friday. You'll have time to get that done on Friday. It should only take you about 20 minutes to get this done. The other thing I want to tell you about, this exit slip will need to be completed before next class. So the homework, which is a Generation Genius Canvas assignment, is not due till Friday, but this one needs to be done by the next time we see each other, which is Wednesday, just like usual. Okay? So make sure you get me that Google Doc. I know today we kind of went a little fast. We had a lot to get through. But if you do not understand anything, if you need help with something, send me an email. All right? If you guys don't have any questions, you're free to go. I will see you guys on Wednesday.